And then we have our Y. And then we have our shear. Okay. At point X, the element is rotating anti-clockwise. Point Y, the element is rotating clockwise. From here, we can draw our mole circle. Okay. So our mole circle will look something like this, I hope. Hey, hold on. I think I start off from the wrong center, that's why. Our mole circle will look like this. And I'm going to draw a line across. Okay. So we know that this is equal to our XY plane. Now, if you were to use this circle to calculate your tau max, if you are just going to use 2D mole circle to calculate your tau max, you're going to be in a lot of trouble. Why a lot of trouble? Because maximum shear stress don't offer well. Okay. Okay. So now you have to construct what? 3D mole circle. Okay, you have to construct. So when you draw 3D mole circle, we know now for a fact that from here, you have another circle. All right, before I go on, I want to highlight how critical this is. Okay? If you were to just sketch 2D mole circle, the value that you calculate so this is the shear max for the XY plane. Okay. And we know that this is not the biggest circle, is it? Right? We have another one. There is a slightly smaller one. Okay. And the other smaller circle is over here. And we know that this circle over here belongs to your YZ plane. The bigger circle, which is the most important one, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 2, 4, 6, 6.5, 13. We know that this will be your largest circle, and this belongs to your what? Exact plane. Okay. So this final circle that I've just drawn, this is the most important circle. Why is the most important circle? Because it has the largest what? Radius. So this is where we have our shear max for the exact plane. Okay, that's where tau max will occur. So this is where we are going to calculate what is our maximum shear stress. Okay, I'm going to copy this whole thing because I need this diagram over here, and I'm going to go to the next page. So the formula now we are
going to use, we are going to determine, okay, we are going to calculate tau max is equal to stress max over 2. Okay, we go. So in order to do that, what we have to do now is we have to determine two things. Okay, we have to determine where this line is. And this corresponds the distance from here to here. Now, it's very important that you sketch Mohs circle. If you don't sketch Mohs circle, you can get really, really confused and lost, okay? The solution provided in the examples I'm going to give you, they are expert in Mohs circle. They don't sketch them. I want you to sketch them, okay? So this is the stress average on the XY plane, okay? Stress average for XY. So to calculate that, why that's important? That is important because from here, we would like to determine what is our stress max. Because the stress max later on, we have to divide by 2 in order to get tau max. Okay. So from here, our strategy is we are going to calculate that distance over there. And then after that, we are going to determine this distance. And this distance will be for your radius or your XY plane. Okay. So the first thing we have to determine is our stress average XY, which is equal to stress X plus by stress Y divided by 2. Now this is stress Y. This is not capital Y. This is small y. Okay. And then we are going to calculate the radius of our XY plane. And this is equal to our tau max XY, which is equal, right? Which is equal to our stress X plus by stress Y. Okay. I'm going to put a bracket, which is equal to stress X plus by stress Y divided by 2 squared. And then we're going to plus shear XY squared. So what are we doing down here? Okay, is to find the what? This is our RXY. Okay. So from here, immediately we can compute our stress max. So our stress max, hold on, did I write this out correctly? If this is, hold on, let me put in some numbers, okay? If this is 30, this is 10, this will be at 20. Yep, it's correct. So from here, okay, from here, we know that this will be equal to stress average XY plus by tau max XY. So we will write this out. So this will be equal to stress X plus by stress Y divided by 2. And then plus the whole thing square root of stress X plus by stress Y over 2 squared plus by shear XY squared. And then finally, tau max will be equal to stress max divided by 2. Okay. So again, we just put this equal to half, and then we put the entire term. Close bracket. Now this is only valid. The expression you see down there is only valid when stress X is greater than stress Y. Okay, both are positive and stress Z is equal to 0. And also, this is only valid when shear XY is equal to shear YX. They are not equal to what? Equal to 0. Okay. So this is one case. Okay. Now, if you do have another case, okay, so this is case number 1. Then we have case number 2. Case number 2 occur where stress X and stress Y are both what? Under compression. When that is the case, when it's under compression, okay, so I'm just going to draw the element. So now both elements are in compression. So the formula changes because now it's in compression. Your maximum shear now is now equal to the stress minimum divided by 2. Okay. So rather than maximum, now we draw minimum. We use minimum. So I'm quickly going to sketch out the Mohs circle. So what is going to happen now, right? So everything is in compression. Okay, so this is our normal stress. Shearing stress element rotate clockwise and anti-clockwise. And we will label this as point X, point Y, and this is point Z. Okay. And we know that again, this is where our point Z is. And we're going to assume okay. This is your and then you have your shear. Right? So this is our stress Y. We assume that stress X is more compressive. So stress X, the element will rotate in anti-clockwise direction. Y, it'll be in the clockwise direction. Then we draw a line across. Then we sketch our Mohs circle from here. And now you can see Y is compression. Okay. Oh, hold on. Did I got this right? 4, 4, 4, 5. Yeah, I got it right. 5, 3, 2, go. All right. And then the other circle, and then we have our final circle. 2, 4, 6, 8, 10, 12. 2, 4, 6. And this is our final circle. Okay. So we know that over here, now this corresponds to our stress mean. And with our stress mean compression, the shear is an absolute value. So this is equal to tau max is equal to stress mean divided by 2. Absolute value. Okay. Right, I'm going to stop here. Tomorrow, we're going to do another case. Then after that, we're going to do that example that I'm going to show you. Okay, the example will take us about 2 lectures.